So I want to take a minute here to discuss the relationship between gravity and orbits. So what we have going on here is this simulation, very high tech, a tennis ball representing a planet and this beautiful sun drawn by my expert artist self here. And we're going to show an orbit. It's this elliptical orbit. No, it is not a circle. We're going around in this ellipse shape. You might be thinking about what's the eccentricity of the circle already, or the ellipse. And we're going to note some things about this pattern. So as we come down here, the tennis ball is going really slow out here at that helion. And then as it gets closer to the sun, it's going to speed up. It's going to go much, much faster towards the perihelion. And then we'll slow back down again as it moves back out towards that helion. Now, I'm going to start this simulation over here. When we're far away, we have high distance, we have very low force. But as we move closer, the force of gravity will increase and increase and increase and increase. And this makes sense if you think about that gravity formula. Distance is on the bottom, and so higher distances will make for less force. Now, similarly, in a moment, I'm going to start talking about acceleration. You'll notice that as we get down here, we're going very fast. And this is because the force, this is when we're close to the sun, the force is very great. And you might remember force and acceleration are related. Force equals mass times acceleration. So we're far away from the sun. Our acceleration is very low. We have very little force, not a lot of strength to accelerate ourselves forward. And then as we move towards the sun, both the force and the acceleration increase as our distance decreases. Because close to the sun, we have a lot of force and we're able to change our velocity and direction very quickly. Now, you might want to notice also for a second that velocity and direction both change for acceleration, right? So when we're taking that corner very fast, some of that acceleration is actually in that turn. Now, lastly, I want to talk about potential and kinetic energy. So when we're far away from the sun here, we have a lot of potential energy because we can fall towards the sun, right? There's all this space to fall towards the sun. That's going to be our potential energy. But as we get close, we're moving very fast. We have all this kinetic energy. And so there's this nice relationship here, right? Which is as you move away from the sun, you're gaining more and more potential energy and lowering your kinetic energy. This might remind you of that skater simulation we did. When you're high up, you have a long way to fall. And so you're really high potential energy, really low kinetic energy. And then down to the bottom, you're going really fast. And so you got all that speed, all that energy of motion is kinetic energy, which will cycle through and pull you right around the sun very quickly. So again, out here at the aphelion, you're going the slowest, you have the most potential energy, you have the least gravitational force, the least acceleration. Down here at the perihelion, you're going to have the most kinetic energy, the most acceleration, the most acceleration, and then the most force from gravity. Thanks, y'all.